name is Anthony Millis. I'm from Veolia Water Technologies, and I'm welcoming you to the healthcare webinar today. I would like to invite our Australia and New Zealand healthcare business developer, Cameron Clark-Bates, who will be presenting the webinar. I will say goodbye and I'll hand over to Cameron now, and he will take over the presentation. And yeah, I wish you all the best.
Thanks, Anthony. Welcome, everybody. As Anthony said, my name is Cameron Clark-Bates. I'm the ANZ healthcare business developer for Veolia. I'm based up in Brisbane. And yeah, for the last 12 months, I guess, that's primarily where I've been with the lovely COVID scenario we've had. But ordinarily, I'm travelling around Australia and New Zealand on a regular basis, visiting all the hospital sites and healthcare sites. Yeah, so I'm here today to talk about water treatment design around AS4187 for CSSD departments in hospitals. This is a follow-up to a previous presentation we gave, hoping to catch anybody who may have missed it the first time. We are getting into the back end, I guess, of compliance requirements for this standard. Yeah, today we are going to talk about, first of all, we'll go through the AS4187 water quality tables from section 7, and we'll then talk about the water treatment solutions that are required to meet them, covering the pre-treatment, reverse osmosis, distribution and storage, disinfection. We'll talk about ring main design requirements and testing regimes and service and maintenance, to give you a bit of a guide there. We'll talk about monitoring and recording, and we'll also talk about audit. Basically, I guess the one sort of thing that's come out more recently in regards to this standard is that the CSSD compliance was required by the end of 2021, but as of last year, I guess they've sort of revised that to say, or at least at minimum, a plan is in place for completion during 2022 or beyond. So basically, you do need to have a solid plan for meeting compliance, even if you have not actually put the equipment in by the end of this year. And that's why we will be talking about the audit offerings and what's involved there to be able to assist you with those plans. But first of all, let's talk about AS4187 section 7 and the water treatment requirements and what's involved. So there's a number of tables in that section, table 7.2, 7.3 and 7.4. And also a clause in 7.2.3.1, which is this first one we can see up here on screen, which is basically looking at the feed water to your CSSD in general. So this is just for your pre-cleaning, rinsing water in your CSSD, and it's just really quite minimal requirements. It's covering water hardness not being greater than 150 milligram per litre, and chloride not greater than 120 milligram per litre. Now, in most cases, your mains water that's feeding your sites will meet these requirements, but not in all cases. There will be some sites, especially rural sites, where your water hardness may be greater than 150 on a semi-regular, if not regular basis, or your chloride levels might be higher than 120. It's relatively easy to fix the water hardness with a water softener in most cases. If you do have elevated chloride, then we're looking at treating the general water for your CSSD with RO as well. But so it is something that you need to make sure that you look at, and it should be part of your audit process. Table 7.2, and this was the original table that came out when the standard first came out, has had some variations, but with the Amendment 2 that came out in 2019, there was the addition of Table 3 and Table 7.3 and Table 7.4. So 7.2 relates to your final rinse water for your washer disinfectors. Now, I won't go heavily into this table because in most cases you're going to be using the same water for your for this final rinse water for your wash disinfectors as you are feeding to your sterilizers, and the sterilizers come at table 7.2. So in most cases we're going to treat water to table to 7.4 for sterilizers. In most cases we're going to treat your water to table 7.4 for all your equipment because it's the higher level requirement. The only variations on that would be if you have a very large CSSD, where you may separate your loops for your washers versus your loops for your sterilizers, though that is not common. So the key things here is really just you've got a bacteria count less than 100, endotoxin less than 0.25, and a conductivity less than 30 microsiemens per centimetre. If we then there's table 7.3, which is your endoscopy water for your endoscopes. With endoscopy, really the focus is around bacteria, and so an endotoxin, as you can see there, less than 10 CFUs for your bacteria, total bacteria count. So really, again, it's something sometimes we look at your endoscopy as a part of the solution, though in a lot of cases you're just using your basic CSSD water with some bacteria filtration prior to the washers to achieve that level. So this is our main table, table 7.4, that we're typically working towards when designing a water treatment solution for your CSSD. So this was introduced in 2019, and it did bring the conductivity level down to 5 microsiemens or less, which is a decent jump. It also has more components that we need to double check and make sure that we're covering. And of course, you've got the bacteria and the endotoxin count that's in table 7.2 is obviously relevant here as well. Alrighty, so really what it means is we're looking at a conductivity of less than 5 microsiemens, which typically will allow most of the other minerals to come beneath these levels, though silica less than 1 is something that we always need to look at as well. And then of course bacteria counts. So how do we treat the water to meet those tables? So the main thing that I would like to really impress on you is that it's not just putting an RO system in. It is a multiple component solution that you need. There's 3 components, and each component is equally important. So you have your pre-treatment system for your water, which is sediment filtration, carbon filtration, water softening before your RO plant. Without your pre-treatment system, your RO plant will not work, either will not work and provide you the water quality specified, or else the RO plant will be quite costly in consumables and will not be as efficient as it should be. Then, of course, you've got your RO plant, which includes your buffer water, your booster pumps, your membranes, which is the heart of the solution, which is bringing the water down to quality. And then you have your distribution system. Distribution system includes your permeate storage tank, includes your distribution pumps and your ring main, your polishing equipment being UV and endotoxin filters, and of course your loop disinfection system. And it is a critical component of your solution, as all are. So go into a little bit more detail. So let's first look at pre-treatment options. So sediment filtration is basically to take the solids out of the water. It's as simple as that. We are filtering out dirt or organics, anything like that, that even potable water will have some of. So on a smaller system, it may be as simple as using cartridge filters or bag filters. And on a larger system, you're using a backwashing media filter. Now, there are a number of medias you can use. Multimedia is what it's commonly called, but today we have a lot of modern versions of multimedias that are more efficient, last longer, and work better. But that they all do the same thing. And then you have your carbon filtration. Similarly with carbon, on a small system you can get carbon block cartridges, which will be appropriate. And on larger systems, again, your automatic backwashing carbon filters, as we see up here in the picture. And carbon is there to primarily to remove chlorine from the water. Because we're treating potable water, it's chlorinated from the council, and often in a hospital scenario, the hospital will actually top up that chlorine level to ensure the disinfection of the water throughout the site. And it is important that we remove that chlorine before the RO to look after the RO system. And then you have, you may have, depending on the feed water quality, a requirement for a water softener before the RO as well, to remove hardness minerals being calcium, magnesium, iron, and manganese. And basically, again, to help look after the RO unit. Now, as we mentioned in that table 7.2.3.1, you may need a softener to treat all your water for your CSSD. So that, and in a lot of sites, there is a softener at the point of entrance to the hospital to look after to soften the water for the whole site. So a softener may already be in place, or in some cases, like in parts of Victoria or the Sunshine Coast up here, where you have lovely soft water from the council, it may not be required. So are there other options? Oh, sorry, there are other options. So there are alternatives such as chemicals. So you can use SMBS for chlorine reduction, and you can use anti-scalant for hard water. And both those things are dosed before the RO to look after the membranes. But why would you use filtration over chemicals? Basically because chemicals add more consumable cost, and the biggest one being it's a handling and storage risk, and also your wastewater then has some chemical in it, which you have to think about with your waste stream. So the sediment the filtration, I guess, has less risk and cost associated with it compared to typical chemical injection. And why is it required? Really, it's to look after the RO. It protects the membranes from fouling, from hardness minerals, or from degradation from chlorine, or fouling from organics or solids in the water, all of which reduce the efficiency and performance of the RO. So that's why it's important. So the second stage we talked about of our three-part solution is your reverse osmosis. So for those of you who aren't familiar, reverse osmosis is a barrier filtration solution. It's a semi-permeable membrane where pure water is forced through the membrane and the contaminants in the feed water are blocked by the membrane. It requires pressure to force that H2O through to the other side of the membrane, and it will remove almost all the minerals and bacteria from the water. Never 100%, about approximately 95 to 98% of the minerals and bacteria will be blocked by the membrane. Now, the permeate water quality is not a set value. It is dependent on a number of factors, such as your feed water quality. Obviously, the worse the water is, your permeate is not going to be as pure. Things like water temperature, pH, your RO settings for the pressure settings, the waste flow rate, the recirculation flow rate, all these things have an impact. So it is important that you don't just buy any RO and plonk it in and expect a given water quality. It needs to be designed and set up properly. ROs are also configurable in different ways. So you can have a single pass RO, which you can see sort of described here, where your feed water comes in, you force your pure water through as permeate and your waste as concentrate. Excuse me, guys. But in some cases in Australia, that permeate will not meet our 5 microsiemen requirement. You will need either a double pass RO or alternative. And what a double pass RO does, as you can see in this bottom picture, is take that permeate from the first membranes and put it through another set of membranes to further polish the water. So these things need to be looked at for your site to make sure that the system is designed to give you the required water quality, and you need to be asking for a RO projection to be sure that you're actually getting that result. So what are the alternatives to RO or double pass RO? You can look at a DI system, a deionized resin. You can run water through a ion exchange resin bed, which uses a cation and an anion resin to pull the appropriately charged minerals out of the water. It will not do anything with the bacteria count, but it will pull the minerals out of the water, and it will provide very pure water as far as your conductivity goes. But with resin, it is regenerated with an acid or a caustic wash, which obviously has then an acid or a caustic waste stream, or else you have to replace it. And the resin has a fairly short life. It can only hold so much on it, so it can be very costly if you're going down that way. Where it can be suitable is, for example, if you have an RO system in place, but it's not getting your feed water quality, and you may have only, say, 1 sterilizer, then you could put a DI system after the RO to polish the water further to meet the water for the sterilizer. But if you have multiple units, then that's when the cost efficiency doesn't really pay out. You can also use electrodeionization, which is doing the same thing. It's using electric charge to pull the minerals out of the water. So the water passes through a cell, which has the charge going across, which pulls the remaining minerals out of the water. So again, that can be a good option versus double pass RO. So using RO EDI as opposed to double pass RO can give you that very high quality water. And it can be more water efficient than double pass RO because you don't have a waste stream from the EDI. But so why wouldn't you do that all the time? Well, the one thing you do need to think about is how aggressive the water becomes. So RO water is already somewhat aggressive. Basically, the more you pull out of water, the more minerals you pull out of water, the more it wants to grab minerals from wherever it can to refill itself. It's hungry, if you like. Now, RO water, we're trying to get that down to less than 5 microsiemens. Now, if you put it through RO EDI, then you're going to get down less than 1 microsiemen in most cases, and that then is much more aggressive water. So that means you've got to think about the wear and tear on your systems downstream, because it is a more aggressive water source. Even though it's pure, it is more aggressive. So, and also your consumables with EDI or DI can be costly compared to RO membranes. RO membranes have become more of a commodity consumable today, so they're not as expensive. So they're the things you need to weigh up. So in most cases, the double pass RO, if required, single if you can get away with it, is the most cost-effective solution, though there will be situations where an EDI may be considered. So your final part of your 3-part solution is your storage and distribution. And sometimes I sort of often think this is the most important part. We've produced the water to the given quality, but now we need to maintain that water at that quality all the way to the equipment. Now, the equipment draws water little bit by little bit. So you've got to hold water in a storage tank. So that storage tank has got to have a conical bottom so that you have no dead space at the bottom of the tank where water sits stagnant, which becomes a nice place for bacteria to sit and replicate. You need to have the tank sealed, but it still has to breathe as the water levels go up and down, so it needs to have a proper bacteria vent filter on it, so that as the air is introduced into the tank or expelled from the tank, that you're not dragging in bacteria through that vent. And the tank needs to be made of an appropriate material that it can be disinfected appropriately. Typically that means it's going to be a 316 stainless steel, and if you're using heat sanitization, which in most cases you will be, the tank needs to be lagged to enable you to get the water to temperature and maintain it at temperature for the appropriate amount of time. Then you've got your distribution pump set, which again, you've got high purity water, so you need to make sure that you've got 316 stainless steel internals. You also need to make sure that you've got some sort of VSD control on the pumps so that they can ramp up to maintain water flow around the loop, even when machines are drawing water. So they'll speed up as machines draw water, and then they'll just ramp back down again, so that you've always got water flowing around the loop at an appropriate velocity. And of course, you need to think about your redundancy here. This is, a big, risk point for the site. You've got your water in the tank, you've got to get it to the machines. If the pump goes, you can't do that. So having redundancy in the pumps, in those distribution pumps, is very important. And then your distribution polishing equipment. So it doesn't matter how well you design your loop and your storage tank and your pump set, you've always got joins in pipe work, you've got connections to equipment and connections to your pumps. You've got opportunities for the introduction of bacteria. And once bacteria is introduced, it will try and find a place where it can settle and replicate. So we need to be polishing the water all the time, and that's why the loop needs the water flowing around continuously. It's why you have a UV lamp to inactivate any bacteria that is floating around the loop, and why you have an endotoxin filter to capture that inactivated bacteria or any bacteria shells or casings that might be floating around in the water. So critical components there with the polishing system that you have to have. So with your loop, you need to consider your materials that you're using to build the loop. Now, we would always recommend 316 stainless steel. Number of sites have used high-grade polypropylene. It can, in some cases, handle temperatures high enough to enable for heat disinfection, but it is more susceptible to biofilm growth than stainless steel. Joints are another big thing. Really, we recommend that joints be orbitally welded. There are a lot of press fit solutions being installed and discussed. The risk with press fit is, as you can see here, this is a copper drawing, but it's the same with stainless steel. You slide the tube into your connection through an O-ring. What that means, you've got an overlap here, which is out of the flow of the water, and so that's a perfect spot for bacteria to settle and start a little colony. It also happens to be up against the O-ring, which is obviously a weak point for where you can get some minute bits of air entering the system, which can bring bacteria with it. Remember, especially with the hot water sanitisation, you are heating and cooling the water regularly, which means you're getting expansion and contraction of your pipe. So, getting minute bits of air in through an O-ring is certainly a possibility. So, though heat soak can help to kill off bacteria in these areas, it is a risk point, which is why we recommend welded. Obviously, you need to make sure that you're sizing the pipe, your ring main appropriately to ensure you've got the right velocity and pressure drop through the system. You need water flowing continuously around the ring main at a good velocity. If it's too slow, then bacteria can hang onto the sides of the pipe. So you want water flowing fast enough that creates the turbulence that keeps the bacteria in the flow, so it can be polished out with your UV and your endotoxin filter. But obviously, you've got to balance that against making sure that you haven't got so much flow that your pressure drop is too much and it's working the pump too hard. And of course, your ring main length needs to be as short as possible. So consider your plant location, getting your equipment as close to your CSSD as possible. Also, when you're looking at your ring main, you need to make sure that you absolutely minimize any dead legs. You can see this picture here of a site. We've got our permeate tank here with the ring main flowing around. Here's your equipment here, here, and here. But rather than the ring main going up to the equipment and then to the equipment and then back to itself, there's a dead leg from here to here, and similarly from here as well as a dead leg. So that will not work long term, because you've got this section of pipe where when the machines aren't calling for water, there's going to be no flow in that section. And also when you're doing your sanitization, how is the heat going to get through to that section? And of course, you need to make sure that you're designing your loop with test points, sample points at the start and the end of the loop, and then ideally at each offtake to each piece of equipment as well. Enables you to, if you do get any failed readings, you can try and find where that's coming from. So I've mentioned ring main disinfection briefly a couple of times, but this is key. Unfortunately, you can't just put a loop in and think that it's not going to have any bacteria as introduction, as I've mentioned. So we need to be doing a regular full disinfection of that loop. Now, the healthcare industry has basically agreed that hot water sanitization is the appropriate solution for this. Why? Because it's reliable and it's measurable and recordable. You can measure the temperature at multiple points around the loop and know that it's you're getting heat soak through the whole loop. It can be done automatically. It can be done outside of hours to minimize downtime. It uses a minimal amount of water because you're heating the water up, flushing it around the loop, and then you're doing a dump and it's done. And then you refill with new water. You don't have to flush the system. But it obviously does use heat it does use energy to heat the water, and you do have to lag the ring main. So there is some higher capital cost with a hot water sanitization system, but of course the ongoing cost is lower. Risks with hot water system is fairly minimal, other than if you have a hand rinse tap. Obviously it is a potential for a burn risk if it's not managed properly, if there's not an isolation, or if appropriate training and is done with the staff so that they know not to use the taps during sanitization. So the alternative to hot water is chemical, whether it be acid or chlorine or ozone. Now, yes, these solutions will disinfect the loop. Why don't we typically recommend them for CSSD systems? Basically, the residual measurement is harder to be accurate because the chemical or the ozone can be used up at different points of the loop. So you might use it up in one area and then it gets to another area and there's not as much residual, and it's very hard to know you've got a consistent residual around the loop. Typically, they're required to be done manually. It's not a fully automated process. So you've got labour required, and of course you've also got longer downtime, not just because of the labour, but because you've got to flush the loops. So you've got to make up the chemical solution, flush it through the loop, then you've got to make fresh water and then flush the ring main to get any residual out, and that's whether it's chemical or ozone, it's the same. And then you've got to make up more water and flush the ring main again. And often it will be 3 flushes that are required. So a lot more downtime, also not as easy to do outside of hours. And of course, you're also using a lot more water due to these rinse cycles. You do have consumables as well, being the chemical or the ozone consumables. But the capital cost is often a bit lower because you can look at options of using a poly ring main. You don't have to lag the ring main, but the ongoing costs are higher, and you do have a lot higher risk in the manual handling of the chemicals, all the storage risks. I think ventilation and warning devices for ozone are pretty critical. So what else do we need to consider when it comes to our water treatment plant? Redundancy is a big thing we need to consider. CSSD is a very important part of a hospital. If your CSSD stops, then your surgery stops, and then your income stream stops. So it's certainly a very important part. So we need to look at redundancy for the pre-treatment to make sure that we're not blocking water flow to the RO, making sure that if there's an issue, we can either bypass or that you've got duty standby systems in place. We need to look at redundancy for the RO membrane. That's your production house for your water. So having a dual membrane train with dual booster pumps is certainly very sensible. So if one membrane, if you have an issue with one booster pump or one membrane set, the other ones can take over. Typically, they will both run together during normal operation, so they won't have to work as hard, but it just means that you design so that if required, one membrane train can cover your full requirement. Distribution pumps, as I mentioned earlier, critical area where we need to make sure you've got redundancy there. And some sites will even look at complete system redundancies or even dual loops. Now, though I think that's probably overkill in most cases, there are situations where that may be required. Another thing to consider is your heating method. So we're looking at hot water sanitisation. Typically, people are using electric elements to heat the water, but if you have steam readily available at where your plant room is, or another alternate hot water supply, we can use a heat exchanger to heat the water, which can obviously save you ongoing costs. So it can be a good option. And further to that, thinking about the temperature that we run the ring main at. So most ring mains run at ambient temperature, but you can run the ring main at what we call a hot loop, which is above 65 degrees C. We permanently maintain it at that temperature. So once you've got it to temperature, it doesn't cost a lot of energy to maintain it at temperature. And the benefit of that is you've got a lot less risk of bacteria growth in the loop between sanitizations, because any introduced bacteria is basically instantly broken down by the heat, or blocked by the heat. So it means your UV is not required. You still have to have your endotoxin filters in the loop, but you don't need the UV because the heat's doing the job of the UV. And it also can add to the efficiency of the washer disinfectors and sterilizers. This equipment takes this water we're producing and heats it up for the process. So if we're giving it to the machines at 65 degrees C, they have a much less work to do to heat it up to the temperature required. So you can get more efficiency. You can shorten cycle times because they're hitting the water quicker. So that can be a good option as well. So the only thing you need to consider with your hot loop is that if you have hand rinse taps, obviously it's not going to be appropriate to have a hot loop. So you've got to look at efficiency versus having a hand rinse tap. So your end result is going to be something either like, if you're a smaller site, it might be a little cabinet unit like this picture here, or a larger site, it might be a skid mounted solution like this picture here. These pictures show our Osiris and Thermopure units that are fully complete. So pre-treatment separate, but on the skid here, you can see this is your RO system with your PLC control and HMI screen, your distribution system tank, and all your distribution system here with your endotoxin filters and UV, all on the skid. With the Thermopure units, these little cabinet units, again, all the equipment's in there, even though it's hard to imagine. You've got your storage tank in there, you've got your RO with your booster pump, you've got your pre-filter, you've got your post UV and endotoxin filter, and it's all the heat sanitization equipment is all built into the unit. So everything's on the one skid. So here's a sample PNID of something that of a site. Obviously, in this case, it's a softened water feed, so we don't have a softener shown because the water's already been softened. We've got multimedia filters, their duty standby or dual filters, but say that we can run, if required, we can run one tank. Same with your carbon filters. They'll share the flow until such time that you need to isolate one. Your RO system, again, this one is a duplex RO. There's 2 membrane trains here, again for redundancy. Into your permeate tank, which this one is a 65-degree tank, so it's a hot water loop through your duplex pumps and your endotoxin filters. No UV because we've got a 65-degree hot water loop, and then that's pumped around to your washers and sterilizers. Excuse me, guys. So I get a lot of questions about testing. Testing is obviously very important, and this just gives you a bit of a rundown of your basic tests. Obviously, when you're designing your testing program, you need to refer to your ISO 15883-4 standards. Your basic water hardness free chlorine level, which you're testing before the RO to make sure that your softeners and your carbon filters are working. They're very simple things to test that can either be done by staff on site if they're appropriately trained, or your service technician who's doing their monthly visit. Similarly, with conductivity after the RO to make sure that it's working, can be done very simply with handheld equipment, and same with pH and your general appearance of the water. So those things are easy to test for, and provided you've got a good service provider, they should be able to do that on the spot as part of their regular visits. Your full mineral analysis of your feed water and of your treated water should be something that you're doing about biannually, just to make sure that your feed water source is staying consistent, because obviously you're designing your system based on your feed water that's provided, and if there's any large variations to that, then you may need to make some adjustments to your solution. So that's just something that biannually, and the samples can be taken by staff or a service technician because they're not sanitary samples, and then taken to a lab for testing. Now, your bacteria count and your endotoxin count, which you'll need to be doing probably quarterly, I would say, for your compliance. This is something that really needs to be taken by an approved lab. You need to have hygienic sample points on your loop, and these samples need to be taken in a sterile container. And so really we recommend that you contract an approved laboratory to take these samples and test for these results for you. Servicing and maintenance of this equipment, it's important that you don't put this sort of equipment in and just hope it looks after itself. You need to have people regularly checking on it. They're not really high cost equipment to service, and they are very, very, very reliable. Not much goes wrong with them, but you still need to be checking and making sure that everything's working as it should be. Now, obviously, Veolia offers a range of service solutions. We have service teams in every capital city, and are readily available. And we offer packages, from 1 year to 5 years as required as part of our aqua service teams. We have our 24/7 hotline. We offer discounts with our service contracts on our labour rates and spares and so on. We provide reports with each visit, and we test for the required parameters other than the lab tests to meet your compliance requirements. Monitoring and recording is, following on from service, is also important. Now, having remote monitoring for the equipment is ideal, because it means that your service contractor can assist you to monitor your equipment and catch anything before it becomes a problem. Now, we at Veolia, we have what we call HubGrade portal, formerly known as Aquavista, which is a full remote monitoring system. We can see basically the screen of the RO, we can see remotely, as can hospital staff. But it also has some other advantages. Not only do we get full remote monitoring, it gives you notifications and alarms when service is required, or it tells you what consumables are required, when the next service is due. It can store your manuals and technical information. And so it's a great program that works very well. And I think it's a standard offering with all our equipment. And then there's an ongoing, obviously, fee for services after your first period. What we're doing a lot of at the moment to assist sites with getting up to speed is providing audit services for sites. This is, if you haven't already started, then it's obviously critical you get onto your plan for your compliance upgrade, and an audit is where you start. So when we come to site to do a CSSD, AS487 CSSD water treatment audit, the information that will be coming to gather will be the details for each washer and sterilizer and tap in your CSSD that requires RO water feed. We'll be looking at the volume of RO water that's required for each unit per cycle, how many cycles per day, how many hours per day it's operating per unit, whether the draw rate of the equipment when filling, and we also look at the future growth requirements for the site. So, you might have 3 washers and 2 sterilizers, but you've got a space there for a 4th, or it might be for a 4th and a 5th, and so on. So we will allow for that so that you're not getting caught out down the track as you expand. And so we understand from this information how much water you need per hour and then per day, and also what flow rate we need to be pumping around that ring main to make sure that we can feed the equipment as well as get a continuous flow back to the tank. We'll also look at location of where we can put the equipment, accessibility for things like power and water and drains, and making sure it's close to the CSSD, how the ring main would work. We'll also get feed water samples so we can get a feed water quality analysis done and check the pressures to the plant room. We'll discuss ring main temperature preferences and heating methods, and we'll look at whether there's an existing ring main that can be used or whether it's going to be completely new, and what the access is like, where that ring main can be run, whether you've got space in your roof, whether you'd run it on the outside of the wall or and so on. We'd look at what sort of in-house capabilities are with your in-house technicians in regards to service and monitoring. Discuss things like in-house BMS and remote monitoring requirements. Do you need a remote screen at a nurse's station, for example, to let people know what's happening? And that will enable us to give you a complete audit, which includes an RO projection of what water quality the RO will produce. It will advise you the power requirements that you need, the space requirements for the system, a recommended plant location. It will include a full process description, pre-treatment, RO, and loop. Design recommendations around the ring main, including the process and for disinfecting the ring main and what sort of regime, how often that needs to occur. It'll talk about the training and support offered. It'll of course give you a budget costing for the equipment for the plan, so that you put that plan in place, and equipment lead times, so you understand how long it's going to take to make it all come together. And of course, it will also include estimated costs and the scheduling for servicing, so that you're budgeting not just for the capital requirement, but also for your ongoing costs for the system. So that about covers it today. I hope that was of value to you. I think Anthony has been asking for any questions throughout the presentation. Hopefully, Anthony, is there some questions there to be added?
Yes, hello again. Yeah, we've received a couple of questions. So if you could cruise across to that page, you can see that we've had a few questions and some of the themes that we've covered today. So if everyone is okay, we can go through that together. I think that would be the best way forward. And feel free to also ask any other questions you may have while we're going. It's an open session. There's no restrictions there. So straight off from now, the first question I'll probably put to you, Cameron, is number one, which is, can you elaborate on the RO stages of purification? I know that, is that something you can elaborate on?
Yeah, look, I guess, so the RO itself is simply the membrane. So it's a barrier. So it is blocking sediments, minerals, and bacteria that is in the feed water and sending that to a waste stream. So the booster pump is forcing water through the membrane, which is pure H2O, but of course it's not quite. The membrane's blocking, as I say, about sort of 95% of any minerals or bacteria in the water. The purification, so the RO is part of the purification, if you like. It's doing the bulk of the work, but also the pre-treatment is assisting there, so that the softener is obviously removing your hardness minerals, your calcium, magnesium, iron, and manganese. Your carbon's removing chlorine and organics. Your sediment filters removing sediments. And then, of course, once the water's produced, you've still got purification systems in that you've got your UV, which is inactivating bacteria, and your endotoxin filter, which is filtering down to 0.04 of a micron, which captures any bacteria and endotoxin in the water. So, yeah, hopefully that answered that one.
I think that's a good answer. Number two, does your company offer any digital solutions for CSSD water production skids? So what do we offer as a business?
So I guess with that one, we go back to our remote monitoring. That's our digital solution. So our HubGrade portal, and it's a designed for site solution. Basically, for each site, we will set that up. It's a cloud-based monitoring solution that has your complete, I guess, duplicate screen for your equipment, so we can see exactly what the equipment's doing. But as I sort of mentioned earlier, it also stores a lot of other information. You can upload into it all your test results. So when you get your water samples and testing done, it's a place to store all that. It's a place to store all your technical data on the equipment. It has all your service records and your service reports and everything like that. It's all in the one program. And the beauty of it is, especially if you're a hospital site where you've got a hospital group where you've got multiple sites, you can have the one HubGrade page with a tab for each site. So we can link it all together to make it easy to find and monitor for your engineering and maintenance teams. And of course, your warnings also come through that system as well.
Perfect. Next one off the rank would be, what is the typical lead time on offer?
Okay, so our equipment, our Osiris and Thermopure units, which are typical equipment used for this application, manufactured in the UK. And so typical lead time is about sort of 2 to 3 months. Again, it will depend on the equipment required for site. Larger, more specialised equipment may take longer. Say a small Thermopure unit may take less time. Obviously, at the moment, with the current environment, freight is still a little bit, let's say, inconsistent. But the equipment, the lead time for equipment to be built is usually about sort of 12 to 15 weeks. So then plus freight.
Perfect. And the next one is, how is the endotoxin removed, and what is the guarantee that we offer from Veolia?
Okay, so the endotoxin, obviously, part of that will be captured by the RO, But the endotoxin that we're really worried about in the loop, that's why we've got the endotoxin filter in the loop that's constantly polishing that water. So we're pumping the water around the loop continuously, and any endotoxin that's floating in the water will be captured by that filter. Now, as far as a performance guarantee goes, certainly Veolia offers a performance guarantee on the water quality from the RO. We do not build the loop as such, though our system includes the sanitisation solution and the equipment to polish the water in the loop. We don't build the loop, so we cannot offer a performance guarantee on the loop, but we can, I guess, but we do offer a performance guarantee on the water quality from the RO.
Okay, very good. Number 5, how long does the audit process take to complete, and is there a cost? And second part of that question, does the audit cover equipment other than RO plants? Is that possible to get an answer for that, sort of covering the audit process and the coverage of the operation?
Yeah, absolutely. So the audit process is not long. It's simply a matter of us coming to site and probably taking 2 or 3 hours just to, with one of your appropriately knowledgeable engineering team or CSSD, NUM or people who know where all the equipment is, so that we can check all the washers and disinfectors and existing water treatment equipment, and also discuss with your CSSD manager or your engineering or maintenance team, things like how many cycles you're running per day, whether you're running 3 days a week or 7 days a week, and when your downtimes are, and so on. And of course, being able to have a look around, excuse me, sorry, where there's existing plant rooms or opportunities for plant rooms. So typically, if you allow half a day for an audit on site, in order for us to get the audit to you, it probably would be about a week or so. Reason being is that obviously we put together a proposal, and if we are having to get things like water analysed for your feed water, if we don't have mains water quality information and we need to send it to a lab to double check, or if we need to wait to get some information from some of your staff on site about cycle times or equipment and things like that, then so say 1 to 2 weeks would easily be able to get an audit back to you. The audit will cover the water treatment equipment, so we don't look at the sterilisers or washers as anything other than the final endpoint for the water. We don't look at the air quality in the rooms. We don't look at your layouts or your rinsing taps or your storage or anything like that. We just look at the water treatment supplying the CSSD. So it does cover equipment other than ROs, in that it will cover pre-treatment, it'll cover your loop, your ring main, and so on, but it doesn't but it's just that water treatment equipment. Saying that, we do look at both. We do look at endoscopy as well as CSSD, and usually try and give some recommendation around that as well. Cost-wise, if it's metro and we've got staff available, typically we're happy to come out and do this for you. Where there could be a cost is if you're a remote site, we need to fly to site or stay overnight or something like that, then there would be a cost involved.
Very good. Moving on to the next part, I might get you, Cameron, to introduce our colleague Theo from Singapore. He's also had some input in regards to question 5 and may be able to assist in regards to question 6 and 7. So
yeah, sure. Yeah. I'll hand over to Theo. So Theo's a chemical engineer based in Singapore that's part of our healthcare team, a key part of our healthcare team. And yeah, I'll happily hand over to Theo to answer these last couple of questions.
Well, I think I'll take the questions number 7, which is the comparison between the chemical CIP and hot water sterilization. I guess this is one of the hot topic that used to rise by our customer, not only in Australia, but as well as in the region in Southeast Asia and Asia Pacific as well. Well, to answer these questions, I like to answer it from two perspectives, which is number one, the objective of the CIP, or we call it cleaning in place, and the hot water sterilization. And number two, the comparison of both cleaning approaches. Yeah. I think for the first one, the objective of the CIP or HWS is to remove the biofilms or to reduce the viable bacterial count, or we call it free floating bacteria from the loop itself. And the selections is actually covered from the bacteria of construction of the system itself. And in this case, I'm referring to the main ring or the distribution loop, the CSSD water. To me, hot water sterilizations considered as a continuous sanitizations, which is continuously hostile conditions to prevent biofilm formation. And hot water sterilization is very powerful to kill the naked pioneer cell. Yeah, and the cell don't survive long enough to plant and grow within the main ring itself. And I'll consider the heat sanitization as easy sanitization approach because it can be proceeded in a short duration if done it frequently, per se, by every week or every month within the 45 minutes, 1 hour, 60 minutes or less than that. And it could be automatically adjusted or even initiated from the system itself. Yeah, and it's easily to generate and remove and verify of the remover because we like presented by my colleague Cameron, we have several temperature sensor to test the water temperature during sterilization processes. And if the loop is operate at 65 degrees Celsius and above, it is considered self-sanitized. Yeah, and on top of that, we may consider another continuous sanitization method for the cold loop, which is ozone. For CIP or the cleaning in place, to me is towards intermittent sterilizations, which I also consider as occasionally hostile conditions that may allow biofilm formation between the sterilization processes. Yeah. CIP, in fact, is easy to attack the naked cell, but it's more difficult to attack biofilms formation within the main ring itself. And ideally, it should be done often enough to avoid substantial biofilm growth within the system. The example of not so easy approach could be the hypochlorite, which is a chemical that we use more on the oxidization agent. Yeah, the hydrogen peroxide, min care, ultra clean, caustic, or chlorine dioxide. To me, CIP is considered as not so easy approach that is tend to be done infrequently because of their difficulty, maybe their toxicity, or the longer durations compared to hot or heat water sterilizations. Not only longer, but also it takes longer time for rinsing out of the toxic residue and its verification process itself. Some of you may ask, yeah, how often is enough? To me, it is depending on the procedures and the continuous monitoring of the system performance to achieve the balance of the system downtime and the healthcare center operation requirement. And final reminders, the infrequency of cleaning is also leading to the inefficacy of the biofilm control result. So you could engage us further for details. Yeah, I hope I answer question 7 well enough. And for question 6, is more on the dead leg. Yeah, Anthony, should I continue on that? The dead leg is actually defined, not really defined at 3D, 2Ds, or even 6D from the main branch of the main ring itself. But to us, it's more towards the procedures to control or to flush the water out from the system before or after the sanitization process. The dead leg definitely will contribute to the biofilm formations This is why during the engineering design stage, we'll try to minimize the dead lag as much as possible to control it to less than 3D. Some customer would like to have 1.5D to achieve a better sanitization results. Yeah. I guess I answer questions 6 and 7 well. And if do you have any question, you still can post it on our chat room here. Yeah, Anthony.
Sorry to interrupt, Theo. It's Anthony again. We did get another question. I think we can elaborate on this question. Is what kind of certification is available from Veolia in regards to healthcare, in regards to this particular part of our offering? Can you elaborate on that?
Certification itself is basically coming from the factory acceptance test, the site acceptance test of the system itself. Before the system is being delivered to the customer site, usually we'll conduct a round of factory acceptance tests to make sure that the material or the material constructions that we use from in contact with the water, from a matter or even the gasket perspective, we do have the certifications to the FDA requirements, and all the sequence of the operations will be tested at our factory prior to the delivery of the system to the customer site. And when the system is reached the customer site and for the post installations, we will commence the site acceptance test as well. The site acceptance test is to make sure that what we have been conducted in the factory acceptance test is matching with what we're going to test on the site to deliver the same performance, the same guarantee to our customers. Yeah, I hope I answered the questions well, Anthony. Thank you.
Thanks, Tia. That was very good. I think we'll invite Cameron back so he can also provide any comments. But just as a reminder to all attendees and everyone joining us today, that we will send a follow-up email to anyone that couldn't attend. So please share that link with your colleagues so that they can view the presentation. So it will be recorded and it will be available on our social media platforms. And yeah, I'll hand over to Cameron, who has his contact details on the page, and he can assist you and wrap up the presentation accordingly.
Thanks, Anthony. Yeah, look, I thanks everybody for attending and for your attention. As Anthony said, my contact details are there on the page on the screen at the moment. Feel free to give me a call anytime. As mentioned earlier on, I'm based in Brisbane, but we are back to getting back to travelling around the country again now, and we do have our teams, obviously, as I say, all around the country. So we are available to come out to site. We happy to have remote meetings with you if preferred, and always keen to be part of your planning and project stages for any water treatment requirements in your healthcare sites. Obviously, CSSD AS487 is the big topic still at the moment, but we're here to help across the board for water treatment on site, whether it be potable dosing, top-up dosing, or whether it be general site softening or water treatment, your cooling towers and heat exchangers, all those sorts of things. We can help you out as well. So yeah, look forward to talking to you and being in touch. Thanks again for your attention.
Thank you, everyone.
Thank you, everyone. Bye.